Good afternoon, I'm Tomasz Rozmaric and I'm a PhD student at the Medical University of Vienna. I'm working at the Department of Pediatrics and Adolescent Medicine under the supervision of Dr. Maximilian Seidel. The aim of my PhD thesis is to elucidate the effect of B12 deficiency on the DNA methylation in whole blood, and then use this knowledge to develop a general newborn screening to identify B12 deficiency in the newborns. B12 acts as a cofactor in several metabolic pathways involving nucleotide, neurotransmitter, and myelin phospholipid synthesis, as well as DNA methylation. The deficiency manifests itself in the infants as failure to thrive, cerebral atrophy, developmental delay, and in adolescence it has been correlated with lower fluid intelligence, working memory, and attention. The reason that the deficiency exists is basically because of there can be DNA mutations in the pathways involving the processing of B12, as well as host microbiome interaction, gastrointestinal inflammation. Meat and dairy are the primary sources for humans to ingest B12, and it is actually estimated that roughly 3% of the general population in the United States have severe B12 deficiency, and this seems to be also reflected in the newborns. However, currently less than 1% of those newborns are identified as B12 deficient by the screening programs, and the reason for that is the unreliable biomarkers, because we need several to diagnose the deficiency, as well as they require some invasive methods such as intravenous blood draw. So if you have a small infant, this is quite invasive for them, as well as the requirement of an expensive machine, such as a mass spectrometer. And as said, we wanted to solve this problem by developing a method, and we are going to do this by first forming two cohorts consisting of 20 newborns, one of the groups being B12 deficient, and then extract the DNA from the dried blood spots and perform reduced representative bisulfite sequencing to obtain the information of the DNA methylation for each individual. And then we are going to compare this data, and hopefully we are going to find specifically differentially methylated regions. And based on that data, we are going to use qPCR and restriction enzymes to develop the method. And hopefully this method works, so we will be able to help these B12 deficient newborns reach their full developmental potential, which they otherwise couldn't. And I think I would be proud to be able to do this.
Thank you, Thomas, for this very interesting presentation of your very important project. I will divide the feedback into the general presentation and then the words. You spoke in very good, complete sentences, and you were nice and slow. I think perhaps you could have stressed it was vitamin B12, because perhaps not everybody is clear what B12 is. Okay. You work with it every day, and I think that's something I would have mentioned at the end. And I think you could also open your mouth a little more. You remember those exercises I taught you at the beginning? I think you could practice those. The vocabulary was very good. Guess which sound I think you should practice?
Dairy.
Dairy is one, yes, but also generally the TH.
TH.
Yeah, this is for everybody a difficult problem. I like the words you used. There was elucidate and deficiency. Thrive is also a very good, important word if you're working with small babies. And invasive. That's a very difficult word because of all the V's, but you managed that very well. So thank you very much for giving us your time, and I hope that you will be successful in finding biomarkers for vitamin B12 in your project. Thank you.
Thank you very much, and thank you for your feedback.
My pleasure.